Problem number 78 on page 228. We are told that we have a sample of air that is made up of nitrogen, oxygen, and argon in the mole fractions of 78% N2, 21% O2, and 1% argon. We need to find out the density of the air at standard temperature and pressure. Standard temperature and pressure is abbreviated STP. At standard temperature and pressure, the temperature is 273.1 Kelvin and the pressure is 1 atmosphere. To determine the density of air, we're going to use the ideal gas law. Knowing that density is mass over volume, we need to rearrange this expression so it represents mass over volume. Knowing that moles, N, is mass over molar mass, we can substitute this into the ideal gas law and come up with this expression. Then rearranging this expression to solve for mass over volume, which is density, you then get this green expression, which tells us the mass over volume, which is density, is equal to the pressure times the molecular weight divided by the universal gas law times temperature. Now substituting in the variables we already know into this expression that we just rearranged, you'll see that to determine the density of the air, we need the molecular mass of the air. What's its molecular weight? To do that, we have to go back to the information originally given to us in the problem, the mole fractions. The problem stated that air is composed of 78% nitrogen, 21% oxygen, and 1% argon. If we assume we have 1 mole of air, then that 1 mole of air would contain 0.78 moles of nitrogen, 0.21 moles of oxygen, and 0.01 moles of argon. To determine the molar mass of air, what we need to do or perform is a weighted average calculation. We're going to take the percent of nitrogen as a decimal times its mass plus the percent as a decimal of the O2 times its mass plus the percent of argon as a decimal times argon's mass. Substituting in those values. Calculating. You'll then determine that 29 grams is the mass of 1 mole of air. We learned how to perform these calculations all the way back in the beginning of the year if you reference Chem Activity number 2. You'll see this calculation for weighted atomic average. Now that we know the molar mass of the air, we can then take that number and substitute it in here. Doing so, all we have to do is then perform the calculation, and you're going to determine that the density of air is 1.3 grams per liter. Questions?